We said that chemistry studies ordinary matter, that is made up of atoms, molecules, and ions. Let's talk about atoms first. What exactly is an atom? If you have some idea, you can pause the video and try to define it. Now, let's look at the following definition. Atoms are the smallest constituent units of ordinary matter that have the properties of a chemical element. As you read this definition, you may have a number of questions. Okay, we established that pretty much everything around us is made of ordinary matter. But it may not be quite clear what kind of properties this definition is talking about, and we haven't yet defined a chemical element. When you are looking at a definition, note down any questions that you may have about it. And if you encounter a term you don't know, always look it up. For instance, if we look up chemical element, we will learn that it is a species of atoms having the same number of protons in their atomic nuclei. So now we have learned that there are atoms of different types or species, that they have something called an atomic nucleus, another new term, and that what defines the species of an atom is the number of something called protons in the atomic nucleus. If we look up atomic nucleus, we will learn that it is a small dense region inside an atom that consists of protons and neutrons. So an atomic nucleus is a part of the atom, and protons and neutrons are its building blocks. We don't yet know what they are. Trying to figure out a definition may sometimes feel like going down the rabbit hole. You look up a term, and in the definitions there are more terms that you don't understand. It is important, however, to get to a point when you actually feel that you understand what the term really means. Don't get discouraged. Remember that no matter how long you fall down the rabbit hole, you will eventually get to the bottom. Here is Richard Feynman, one of the most famous physicists of the past century, talking about how his dad prompted him to always stop and think what things really mean.
We had the Encyclopedia Britannica at home. And even when I was a small boy, he used to sit me on his lap and read to me from the Encyclopedia Britannica. And we would read, say, about dinosaurs. And maybe it would be talking about the Brontosaurus or something. And it would say something like, or the Tyrannosaurus Rex. And it would say something like, this thing is 25 feet high, and the head is 6 feet across, you see, and so. And so he'd stop always and say, let's see what that means. That would mean that if he stood in our front yard, he would be high enough to put his head through the window. But not quite, because the head is a little bit too wide and would break the window as it came by. Everything we'd read would be translated as best we could into some reality. So that I learned to do that everything I read, I tried to figure out what it really means, what it's really saying by translating. And so I used to read the encyclopedia when I was a boy, but with translation, you see. So it was very exciting and interesting to think that there was animals of such magnitude. I wasn't frightened that there would be one coming in my window as a consequence of this, I don't think. But I thought it was very, very interesting, and that they all died out. And at that time, nobody knew why.
So how can we explain what atoms are in the simplest terms possible? A good place to start is the atomic hypothesis. 2,500 years ago, the ancient Greek philosopher Lysippus and his student Democritus claimed that everything is made up of tiny particles that cannot be divided further. They called these particles atoms, meaning indivisible in Greek. So their reasoning was that if you were to take an apple, for instance, you could cut it in half and then cut each of the halves in half and then cut each of the quarters in half and so on. But at some point, you would get to really tiny pieces that could not be divided further. Those indivisible particles would be atoms. The idea that matter may be discrete, that is, that it might consist of indivisible particles, also came up in other ancient cultures. However, at that point it wasn't a scientific idea, because it could not be verified. It was just a speculation. Speculations about what the world is made of were popular at the time. For instance, the philosopher Thales from the Greek city of Miletus, that is located in present-day Turkey, claimed that everything is made of water. Another philosopher, Anaximenes, also from Miletus, said that everything is made of air. Yet another philosopher, Anaximander, you guessed it, from Miletus as well, argued that everything is made from a hypothetical substance he called a peiron. Don't ask me what that is. None of these claims are true, of course. The atomic hypothesis, however, ultimately proved to be correct. Thousands of years later, people found evidence suggesting that everything was indeed made up of tiny particles, atoms of which there are many different types and which combine in different ways. Later on in the course, we will look at some of the early experiments that suggested the existence of atoms. These experiments illustrate well how science works. We make carefully staged observations of natural phenomena, then come up with a hypothesis that rationalizes what we are seeing. Then test whether our hypothesis is correct by using it to predict something about natural phenomena, and checking whether our predictions are correct. Nowadays, scientists even have tools that allow us to see and move around individual atoms. One of these tools is a scanning tunneling microscope, or STM. Here you can see a few images created by placing individual atoms on a surface. Each dot in the letters is an image of an atom. So keep in mind that ordinary matter around us consists of discrete tiny particles, atoms. Today we know 118 different types of atoms, of which 94 occur naturally on Earth and the other 24 are synthetic or man-made. We call each of these 118 types of atoms a chemical element. One thing that Lysippus and Democritus were wrong about is that atoms are the smallest particles in nature that cannot be divided further. Atoms are fundamental building blocks of ordinary matter, however they themselves are made of yet smaller particles, and their composition actually defines what kind of an atom we have and how it can connect to other atoms.